in calculus, a lot of these types of problems that we're going to do throughout this year used to be solved in a much more complicated way, and they weren't really looked at as the same types of problems until they came up with the limit process. Okay? Usually attributed to either Newton or Leibniz. They kind of fought about who came up with it. But it is something we're going to start off with in its basic form and then try and work towards where it gets more complex. So we're going to try right now, and I'm going to give you a little bit of time right now to try and graph this piecewise function. I know with the new smartboard software you can kind of see it on the smartboard already. But why don't you just take a little bit of time. I am going to pause the recording so that you have time to actually try and do this piecewise function and get it graphed. It should fit on what you have. But those listening to the recording, actually please try this instead of just having the answer pop up. All right, so once again, if you are listening to this, hopefully you actually took the time to try and get this graph, because there was something a little bit different. I don't think it happened a lot before, and that was the third one down, where y just equals 2 when just x was 2. So that might be a little bit different. So this first one here, I could probably, this first one is negative x plus 1. That's only when from 0 to 1. So you could actually just put in 0, put in 1, find out where it's going, and do all those things. But I think once I click this, it does something like that, right? There's your first one. Agreed? Now the next one is y equals 1, which is just a horizontal line, and that's from 1, and basically it does kind of, here it's included, and here 1 was not included, right? So you have to see, does it connect, does it not connect? When I put 1 into this first one, I get 0 though, right? And then when I put 1 into the other one, I just get 1, and so that's a slight problem. And so then you kind of end up with that piece, right? Okay, so there's an open hole at that point when you go to 2, right? And then this one's kind of the weird one. It's saying whenever x is 2, y is 2. That's just a point. x2, y is 2, right? The next one, again, is a line from 2 to 3. So it does that. And then the last one does that. So any questions on any particular part, or just in general how you would get that graph? Because it does have to be accurate for us to get this. Do you notice that down here at 1, 0 it is open circle? Okay, everybody see that? Because the point's not actually there. What you have just done is you have shown now all of the points where this particular piecewise function is defined. Right? We know that there is a y value result, right? Given certain x values. For example, if I said, what is the y value when x is 1.5, is that something that you should be able to tell me at this point? When x is 1.5, should you be able to tell me the y value? Yes, and what is it? 1. Now you should be able to go over here and say, okay, it's 1.5, so it fits in here, so there's the response, correct? Or you could look here and say, oh, it's 1.5, and so the response is right there. Agreed? That is not what the limit process is. The limit process is saying, as it gets closer and closer, where is it going? What is happening to that output? And notice how I use it. The outputs here are usually y. The inputs in this case is normally x. Okay? So that's going to be the hardest thing for you when we're talking about the limit process. It's where it's going, not where is it defined. Where is it going? What is it getting closer and closer to? Okay? Without ever getting there. Okay? Well, let's try a few questions. So the very first one you have, this is notation. It's basically saying, what is the limit as x approaches 0? And you see there's a little plus sign up there. Can you see it on yours? That means from the positive direction. Well, what's the positive direction? On an axis, like the x-axis is on the right-hand side, right? So that means what is the limit as x approaches 0 from the right? So let's just choose something to the right of x being 0. Do you agree x is 0 anywhere on that axis right there, correct? That's where x is actually 0. So pick anything to the right of it, anything you want. Obviously, I could go way over here and choose 20 as an x value, but I don't have anything graphed, right? So that's probably a bad choice. Choose something relatively close, like a half. Do you agree if I choose x as a half, I end up right there as a response, y value, correct? What if I get closer? So I'm going to get closer to 0 from the right. That's my response. Agreed? What if I keep getting closer and keep getting closer? Do you agree the responses are tending towards that value, correct? Okay, that's what they're getting closer and closer to. Are you with me on that? So the limit as x approaches 0 from the right is whatever it's getting closer and closer to as a response, which in this case is 1. Do you agree it keeps getting closer and closer to that response? Okay, or that output? So who can tell me what letter B is asking? What is it? Just read it to me. What is the problem? How would you read it to somebody? The limit. Very good. The limit as x approaches positive 1 from the right. Okay? So what did we do this last time? We just picked something to the right of the x value of 1. I think we could agree the x value of 1 is right there, correct? So I have to pick something to the right of it that's actually on my graph. So would we pick maybe 1.5, right? What's the response at 1.5? It's right there, agreed? That would be the response, according to my graph. Well, what if I get closer to 1? I'm supposed to approach it, right? That's my response, agreed? As I keep getting closer and closer and closer, where does the response go? It keeps getting closer and closer to that value, correct? And what value is that it keeps getting closer and closer to? 1. And in fact, that whole time it's just flat out 1 that whole time. Okay, but it is getting closer and closer to that answer. Is letter C asking the same question? Is it very close to the same question? Except now it wants to know the limit as x approaches 1 from the left. So choose something to the left of it. Okay. And it's the left. We know that because of the little negative symbol, right? That's the negative end of things. Is the left-hand side. So choose something to the left. Well, let's choose that half again, right? That's the response, right? So keep getting closer. Now that's the response. Now if I keep getting closer to that, that's the response. That's the response. Is there actually a response down there? No, here's the first one that's going to be weird for you. Even though the response is not there, is it still getting closer and closer to it? Is the point there? The point isn't actually there, but it is getting closer to that mysterious open circle we have down there, correct? So believe it or not, the limit process says, yes, it's getting really, really, really close. It's never really going to get there, but the limit process is trying to tell you what is it getting really, really close to? And what value does it keep getting closer and closer to as it works its way down? Keeps getting closer and closer to 0 as a response. Does it ever actually get there? No, and that's the hardest thing for a lot of people. It's never really going to get there, but it does get really close. Okay? Everybody good with that? Okay, now what's different about letter D? There's no plus or minus. So that means the limit as x approaches 1 period. And this is what we're going to be saying. And for this to work, it has to approach the same value from both directions. So from the right, it approaches 1. Okay, notice I'm choosing the same value. From the left, it approaches 0. Are they approaching the same value? So this one's going there. This one's going there. Are they approaching the same value? They are not, so this limit does not exist because they do not approach the same value. If they approach the same value, guess what? You write down that value. That is the answer. Okay. A, B, and C are what are called one-sided limits. And then D is just normally referred to as just the limit, or a two-sided limit if you want to call it that, because it is concerning both directions. How are you doing so far with this limit idea? So is it actually asking for the y value or the response? No, it's asking for what is it getting closer to, not what is it. Okay. So let's try this one. The limit as x approaches 2. Let me be honest with you. If you get this one, you've kind of got this limit process figured out. How about the limit as x approaches 2 from the right? So let's just pick something to the right of it, like 2.5. That's the response. Agreed? On my graph, that's what would happen. And then as you get closer, you keep working your way in. It keeps going this way, correct? So what is it getting closer and closer to as you get going? Be very careful with this answer. Again, where is it getting closer and closer to? It's getting closer and closer to that open circle, right? And what value is there? It's 1. Very good. Because did I ask what the value I get when I put 2 in? Is that what I asked? No. I asked what is it getting closer and closer to, because that's what limit means. That's what it stands for. How about if we were to do this one from the left? So you pick something to the left and you work your way in. What is the response getting closer and closer to? It's getting closer and closer to 1. So can I give you the overall limit? Yes, because they are approaching the same value from the left and the right. And so the answer is 1. Is that where it's actually defined? No, the actual point is 2 comma 2. Did I ask you? Wow, that was really good arrow. Did I ask you where it was defined? No, I asked you what the limit was. What is it getting closer and closer to as an output? So there is your end. It doesn't even have to be there. That's the weird thing. Yes? Yes.
But if there are two different ones, it's just
Exactly. Just so that you can hear what was said, is if the two one-sided limits for that particular value are heading to the same place, then that is your overall limit, which is true. If the two one-sided limits are approaching two completely different values, then there is no overall limit for that x value. Yes? Hmm? Ah, very good question. If you only have the one-sided limit, then I can only ask you for the one-sided limit. For example, overall, can I ask you for the limit as x approaches 0 on this particular problem? No, because can I really go to the left of it? I can't. Okay, good question. Mm-hmm. But a lot of times we're going to be dealing with continuous functions, so we can ask just about anything. Okay. Again, we're just trying to get into this idea of it's not asking you where is it, it's asking what is it getting closer to. That's what the limit process is asking.
there's just a point if I'm disregarded.
A lot of times, yeah. Unless I truly sit there and say, well, what is it if I put 2 in? Well, if I ask you that question, well, then you would tell me 2. But that's not what that question is asking. Okay? Why don't you, I'll pause the recording again, and why don't you go ahead, how many more do you have on that sheet? Just these 4? Okay? Why don't you go ahead and try these again on your own, and then we'll come back together and see how you did. All right, let's see how we did. Again, hopefully you actually did pause it. How about the limit as x approaches 3 from the right? As x approaches 3 from the right, we're coming in like this. So where am I actually going? I'm going to what response? What y value? I'm going to 2. How about from the other direction, from the left? I'm also going to 2. Okay, so can I actually say the limit as x approaches 3? It actually is 2. Now in this case, is that actually also where it's defined? Is that actually where the point is? Yes. Is that always going to happen? No. Okay, so keep that in mind. How about, now notice I didn't ask you for both directions this time. I wanted to see what you were going to do, and this is probably where the question came from earlier. How about the limit as x approaches 4 in this problem? Can you take the limit from the left and the right based on the information you have? No, can we do from the left? Yes, and that answer would be 1. Can we go in from this direction? We cannot, and so we cannot answer this question at this time. Okay. Questions? Okay, sometimes you will just be given a function and not the graph, but I figured the graph would be helpful to start off with. Determine if each of the following limits by substitution, if possible. What that means is, a lot of times if I give you a continuous function, do you have to worry about any of these holes and all this stuff that are happening here if the function I give you just keeps going right along? No, if there's no holes or discontinuities, you can just substitute the value in, because it really is just the y value, like it was a couple times. So how about x squared plus 4? Do you believe that to be a continuous function? Is that something that goes on forever? No holes, none of the weird stuff, right? Because that's a parabola that's been moved up 4 from the parent graph, correct? And so we know that's good, so we can actually just substitute 1 in, because all I'm looking for is the y value. That's all I need to know. So what is that? 1 squared is 1 plus 4 is 5. Now for those of you that would like to see that graphically, that is what it would somewhat look like as a sketch, correct? So how about the limit as x approaches 1? From the right and from the left, is it approaching the same value? And does it seem as though it's approaching 5? Yes. So you see, sometimes substitution is easy if it's continuous. How about this one? Do we have any problems in this particular graph? Yeah, we actually do have a problem with that graph, don't we? Yeah, we have an asymptote, but where is the asymptote? It's when x equals 0, correct? You agree with that? If I put 0 in the bottom, we have huge problems, correct? But is that where I'm asking you about? No. So is this graph, think back to your parent graphs, is this going to be continuous everywhere else but 0? As far as the domain is concerned, it is. So guess what? Substitution works again. Because you can just put 2 in there, and you can put 2 in there. And so what do we got? We got 4 over 2. So my final answer is 2. Because here's what this graph would look like. Let's see, it's y equals 1 is an asymptote. And x equals 0 is an asymptote. It kind of looks like this. So as x approaches, this is for those of you that are visual, as x approaches 2, is it approaching the same value? It is from both directions, right? Now, had I asked you about 0, as x approaches 0, there would have been a problem here. Agreed? Because you're not allowed to substitute 0 in. Right? Everybody see how that would be a problem? Okay. How about this last one? That's a -3 in there. Can you even see that on yours? As x approaches -3. Well, let's face it, this also has a slight problem. This actually has a hole. Or no, it doesn't. This has a slant asymptote. But not at -3, so do we have to worry about it? No, just substitute it in and you get, I got 9 over -6 when I did it. So I got -3/2 was the response that you got. Okay. And that's because at the value I asked you about, there were no problems. There were no asymptotes there. And I can show you this sketch if you want. How about D? Can you substitute? The limit as x approaches 0, so can I just put 0 in to the function and get a response? Yeah, what do you get as a response? Square root of 5. Now how about this graph? This is the, well, I probably should have made it a little further over. This is the square root graph moved, nope, left 5, right? So it'll be something like that. So as x approaches 0, are they both approaching the same value? Yeah, happens to be the square root of 5, right? How about the next one, -2? Can I put -2 in? No, why? Because dividing by 0, correct? So that probably means it's either a whole or an asymptote. Agreed? So can we do it by substitution? No. So we put not possible. That's what it says to write here. Agreed? Now, this means not possible by, wow, that's really bad, substitution. Because the graph is not continuous at the point I asked you about. Pretty much I could have asked you about any other x value here and you would have been fine. Now it appears as though I copied D and made F. Slight difference. Yeah, I moved it to the right this time, so if you put 0 into substitution work, no, because we're talking about, what's the problem? Again, not possible because, at least not possible by substitution because of imaginary numbers. And again, if you look at the graph, this one's been moved right 5, and as x approaches 0, is 0 even in the domain of that function? No, so that one's not fixable. Okay, you can't fix F. Right. Oh yeah? Okay. So example 3 is saying, okay, well, hopefully we determined that 2e and 2f can't be solved by substitution. Well, how would we solve them then? Well, in this one here, and again, we're going to review some of this stuff before we go on too far. Obviously, x plus, -2 is a problem. So we have to find out if it's an asymptote or if it's possibly a whole. Who remembers how you find out if it's possibly a whole? And what creates a whole, sometimes called a removable discontinuity? Nothing with reciprocal, no. But I would take a look, can we factor the numerator? Just factor the numerator. We kind of talked about this one just not being possible at all, right? So I'm going to scribble that one out of the way for right now. Let's just try and factor this. So it has to multiply to be 1, add to be 5. Do such numbers exist? What are they? Oh, multiply to be 6, sorry. Actually, the other one works too, doesn't it? Yeah. Well, no. But multiply to be 6, yeah, 2 and 3. So this one, remember, actually, you just bring down. This one's the one that splits. Plus 2x, plus 3x, plus 6. I know a lot of you know that there's a shortcut for this one. Is that right? You sure? Multiply to be 6, add to be 5. Is this going to work? I don't know. Let's find out. X. What's left? X plus 2. Can I get x plus 2 over here? By taking out 3. So my factors are x plus 2 and x plus 3. Okay, so that's what my numerator is. So I could rewrite this problem. X plus 2 times x plus 3, because that's what I just found the numerator is, over x plus 2. Yeah, the x plus 2's do cancel. And remember that we can still find out then where the hole is. We know that x equaling negative 2 is a huge problem here because we would set that equal to 0 to find out where the problem was. So yeah, negative 2 is a huge problem. So what happened is this was rational to start with. But is it rational anymore? Meaning has fraction parts to it? And a variable at the bottom? No, it's just y equals x plus 3. Is that something we can graph? Yeah, you've been able to graph that for years. Y equals x plus 3 is a line. Okay. But at negative 2, there is a hole. So at negative 2 comma 1, there's a hole. Now, I know the graphing calculators can do that. It's best to go to the table because it does struggle with actually putting the big hole in there. So can I now do this limit as x approaches negative 2? Does it approach the same value from both directions? It does. It approaches positive 1. Now, if that was a little bit of a blitz and a little too fast on that one, we are going to cover those asymptotes and discontinuities again before we move on. That's the next couple days, is a review of how to find holes and asymptotes and all of that stuff. Any other questions? And again, that one we found out that it's not even fixable, right, because of the graph. Okay. There's nothing even there. Okay. Any other questions? Yes. Oh, the answer to the first part? Okay. What I did is once we got here, I knew I was graphing y equals x plus 3. So I graphed the line real quick, right, because we could probably do that. And then what I did is I put in negative 2 in for x. And it gave me a positive 1. So I knew that's where the hole was. Okay. And then I said, how about the limit as it approaches from the right and the left? It does go to that hole that I just made, right? And so that's how I knew that it would be a positive 1. Yep. Anything else? You're looking at it kind of funny. What part confused you? The 1? Okay. So do you agree that once I cross this off, it is no longer part of the function? Okay, but does it still contribute to this original function? It does. But once I cross it off, I just graphed y equals x plus 3. You with me on that? I have it graphed up there. Okay. And so what it... Okay, yeah, I knew negative 2 was going to be a problem right from the beginning. Once I saw it crossed off, I knew that's where the hole was going to be then, because that's what made this equal 0. Okay? And so once I knew negative 2 was the problem, I said, well, that's probably one I should really find out about on this line. So I put negative 2 in to find out what y value would happen if I just had a line, and I found out it was positive 1 if you put negative 2 in. Negative 2 on just this graph would actually be there as a point. On this graph, it's not actually there, because I'm not allowed to put negative 2 right there. And so that's how I knew that's where the hole was. Everything else works out. And so then I found out that that's where the limit would be, because that's actually where the hole was. Yep. Again, we're going to review all of those things, how to find all of that before we move on. How about the general limit process in general? Again, it's not asking where is it, it's asking where is it going. Okay? That's the biggest thing. Keep straight. Sometimes is it actually where it is? Yeah, sometimes that's just the answer, but not all the time.